Hello and welcome to another chemistry video. We're talking about gas stoichiometry. In our second example, it asks what volume of ammonia at 500 kilopascals pressure and 80 degrees Celsius can be obtained from the complete reaction of 7.5 kilograms of hydrogen. The first thing I notice is that we are not under standard temperature and pressure or standard ambient temperature and pressure. So we're going to have to use the ideal gas constant. We're going to have to use R at some point in time. But whatever, we'll deal with that when we get to it. It says what volume of ammonia can be obtained. So we're making ammonia. Let's start how we would always start, with a balanced chemical reaction. If we're going to make ammonia, that means we have to be reacting nitrogen gas and hydrogen gas together. So if I react nitrogen and hydrogen gas in a balanced chemical reaction, well, I've got 3 hydrogens and 2 hydrogens. That means I have to be able to make 6 of each. And if I have 2 nitrogens here, I already have 2 nitrogens there. Woo, perfect. We have a balanced chemical reaction. So after we've made our balanced chemical reaction, we want to be able to put our puzzle pieces that we're going to fit together in our stoichiometry problem. The puzzle pieces always go below the chemicals that relate to them. In this one, it's going to be a little bit more complicated than in the last example, but we will work through it together. Absolutely no problem. What volume? This is the big thing that we're looking for. What volume of ammonia? So under ammonia, I will put V question mark. At 500 kilopascals pressure and 80 degrees Celsius. So what I'm going to do is I'm going to put that under the unknown. I'm going to put 500 kilopascals, and I'm going to put 80 degrees Celsius. Oh, that doesn't really work very well for me. 80 degrees Celsius is not something that I like. We're going to change degrees Celsius into Kelvin. So 80 degrees Celsius plus 273 is going to give us 353 Kelvin. So 353 Kelvin. Perfect. This looks a little bit better. 500 kilopascals and 353 Kelvin. What else? 7.5 kilograms of hydrogen. All right, no problem. So 7.5 kilograms H2. Well, the way we convert from one substance to another is using the moles of that substance. So if I want to convert from moles of hydrogen to moles of ammonia, first I need the moles of hydrogen. The way we get moles from mass is using the molar mass. The molar mass of hydrogen is 2.02 grams of hydrogen for every 1 mole of hydrogen. Perfect. With these 2 pieces of information, I can convert between mass and moles. Now, how do I convert from moles of one substance to moles of the other? Well, I'm going to have to use the molar ratio of this chemical reaction. The molar ratio, I'm going to put it off to the side here. The molar ratio of this chemical reaction is unknown over given, so 2 moles of ammonia for every 3 moles of hydrogen that react. Perfect. So now I can go from moles of hydrogen to moles of ammonia, but I don't have any piece of information about the moles of ammonia, and that's where our ideal gas constant is going to come in handy. I'm going to write it in green. The ideal gas constant is 8.314 kilopascal liters over 1 mole Kelvin. Holy guacamole, that's a lot of information. Let's try and put it together. The way we always do stoichiometry problems is start with what we want. Let's try that. What do we want in this problem? We want the volume of ammonia. What is the volume in liters of, ammonia? Well, the only piece of information that has liters of ammonia or liters of anything here is my ideal gas constant. So that's what I'm going to start with. I'm going to start with 8.314 kilopascal liters of ammonia over 1 mole of ammonia Kelvin. All right. What is the unit we want? The unit we want is liters of ammonia. That means we have to cancel out every other unit that is in the ideal gas constant. We have to cancel out everything. Okay, I think we're up to the challenge. Let's first try and cancel out the moles of NH3 because that's going to be the hardest one to cancel out. Well, the way I cancel out moles of NH3 is by using our molar ratio. 2 moles of NH3 for every 3 moles of hydrogen. Perfect. We have now canceled out moles of NH3. Oh no! But we've turned it into moles of hydrogen, so we got to cancel out moles of hydrogen somehow. Well, the other piece of information that has moles of hydrogen is the molar mass of hydrogen. So if I flip it, 1 mole of hydrogen has a mass of 2.02 grams of hydrogen. Okay, that's good. Moles of hydrogen, cancel out moles of hydrogen. Son of a gun. Now we have grams of hydrogen left over. Well, I know what else has grams of hydrogen, and that was the initial mass of hydrogen that we started with. So if I multiply that by 7.5 kilograms of hydrogen. Okay, so what's going to happen is I'm going to take grams of hydrogen and I'm going to cancel it out with grams of hydrogen, but I still have kilos left over. So that factor is still left there. Okay, what else do I want to cancel out? I want to cancel out kilopascals. So kilopascals are in the top here, so I want to put kilopascals in the bottom. We have 500 kilopascals. So kilopascals and kilopascals cancel out. This is fantastic. The only other unit I have to cancel out is Kelvin. So let's cancel out Kelvin multiplied by 353 Kelvin over 1. So Kelvin and Kelvin are gone. Wow. All right, no problem. If I put all of this into my calculator, so I'm going to go 8.314 times 2 times 1 times 7.5 times 353 divided by 1 times 3 times 2.02 times 500. If I do all of that and convert to significant figures, I see I have 2 significant figures here from the 7.5. I'm going to get 15. And then I have to figure out what units I have left over. Well, I have kiloliters of ammonia. So I'm going to be left with kiloliters of ammonia. Boom. Woo! That's what I'm talking about. Okay. Well, that looks like it was pretty successful. I know there was a lot of unit conversions in this problem. And really, I cannot stress that the setup of this reaction is the most important part of doing this reaction. The setup really, honestly, is the most important. Please let me know in the comments below if you have any problems or if you have any questions or any concerns. Thank you. Bye.